Ever pondered the fundamental principles that govern the flow of electricity in a circuit? Today, we're diving deep into one of the fundamental laws of electrical engineering, Kirchhoff's current law, or KCL for short. Picture a busy intersection in a city. Cars are coming and going from different directions, yet surprisingly, no traffic jam occurs. This is because the number of cars entering the intersection equals the number of cars leaving it. Now, replace cars with electric current and the intersection with a junction in an electrical circuit. What you get is Kirchhoff's current law. So, what does Kirchhoff's current law say exactly? It states that the total current entering a junction or a node in a circuit must equal the total current leaving that node. Remember, this law is based on the principle of conservation of charge, which states that charge can neither be created nor destroyed. Let's illustrate this with an example. Imagine a junction in a circuit where three conductors meet. If 2 amps of current flow into the junction through one conductor, and 1 amp flows in through another, then 3 amps must flow out through the third conductor. Here, the total current entering the junction, 2 amps plus 1 amp, equals the total current leaving the junction, 3 amps. But what if more than 3 conductors meet at a junction? The law still holds. The total current entering the junction through all the conductors must equal the total current leaving the junction. Now, what if the currents are alternating instead of direct? Does the law still apply? Absolutely. Kirchhoff's current law holds true for all types of currents, be it direct current, alternating current, or even complex waveforms. Kirchhoff's current law is not just a theoretical concept. It has practical applications in many areas of electrical engineering. It is used in analyzing complex circuits, designing electrical networks, and even in the development of electrical measuring instruments. In summary, Kirchhoff's current law is a fundamental principle in electrical engineering based on the conservation of charge. It states that the total current entering a junction in a circuit must equal the total current leaving that junction. This law holds true for all types of currents and has practical applications in various areas of electrical engineering. Remember, understanding the basic laws like Kirchhoff's current law is crucial to mastering the field of electrical engineering. So keep exploring, keep learning, and let the power of knowledge electrify your mind. Until next time, stay curious and keep asking questions.